a warm welcome for our folks from the Neponset River Watershed Association tonight.
All right, and so my name is Ian Cook. I'm the Executive Director of the Neponset River Watershed Association. If you're not familiar with us, we're a conservation group that works to clean up and protect the Neponset River, which stretches all the way from Gillette Stadium, or if you like to call it that, Boston Stadium, up in Foxborough, all the way down here to Quincy and Dorchester, right by the gas tanks. And we've been around for a long time. We were founded in 1967. We do a lot of work on water quality, access to the river, and for a long, long time, protecting habitats and wetlands, and particularly our salt marshes, has been a big priority for us. You know, the Neponset is the only one of the three major tributaries to Boston Harbor whose estuary and salt marshes survived the colonization of eastern Massachusetts. So it's very special that we have our salt marshes. A number of years ago, almost 30 years ago, we worked to get the state to give a little extra recognition to this area and designate it as an area of critical environmental concern. And really what makes this area so special is it's a very unique environment where you have fresh water coming all the way down from Foxborough and the ocean coming up, and it's all kind of mixing together. So it's not quite the ocean, it's not quite fresh water, and there's a whole host of very unique species and plants and animals and fish that are adapted to this unique environment. A few years ago, when we were working on our strategic plan and starting to think more and more about climate change, we realized that our estuary and our salt marshes are really seriously threatened by climate change. And we set ourselves a goal to save the Neponset salt marshes, whatever that means. And we've spent the last couple of years doing some really interesting assessment and research about this, both looking at the existing conditions of our marshes and also thinking about what's going to happen to them over the long term and what are some of the options to manage them in the future. And we've done that with kind of a dual lens. It's kind of, you know, some of it is ecological. How do we preserve this habitat that we really appreciate? And some of it is a little more self-serving in terms of recognizing that there are a lot of neighborhoods and people and recreational trails that are also very much at risk, and trying to figure out if there are any synergies between these two systems. So I do want to thank all the people that helped us make this project go. And Sean is going to do an official list of the funders. We had some wonderful citizens that participated with us on a community advisory group. And I think in some ways the most important partners we had for this were the three cities and towns around the estuary. So the estuary includes Quincy, Milton, and Boston, and all of them came together to participate in this project to talk about some things that are really challenging issues on many levels. And we've been grateful to have their partnerships. And I think Margaret LaForest from the city of Quincy, what do we call you? Like climate czar? What is your title actually?
I am the Director of Coastal Resiliency and Sustainability. I like to say all things blue and green for Quincy, and I cross all of the municipal departments, so kind of like municipal flogger.
Excellent. Anything else you want to add, or shall we just?
Hello?
Yeah, please do.
Just good evening, everybody. I wanted to say welcome on behalf of Mayor Koch. My name is Margaret LaForest, the Director of Coastal Resiliency and Sustainability. Honored to be a part of the Neponset Stormwater Partnership with my colleagues in government, Heather Liss, our environmental scientist and natural resources, Rob Stevens in the planning department, Paul Costello in the engineering department, our energy manager, Lisa Hanley in the buildings department. We are, the city, you often have a statistic, 27 miles of coastline. There's also 400 acres of salt marsh. We are extremely grateful for the impressive advocacy of the Neponset River watershed. Of the 27 miles of coastline, 2 miles is the Neponset River. There's 25 other miles. One of the things I've been advocating for since this position is that of the Commonwealth's watersheds that we broke into 2 miles of Quincy's Neponset River, the other 25 are the Weymouth Weir watershed that does not have an advocacy association. And if I could either A, scope Creek NepRWA, or copy paste and add on, we are working with some coastal zone management on some technical assistance. and how we can spread this advocacy to our broader community and the South Shore region where we've seen a real disparate gap. So impressive, learned so much from all, anytime that I had the opportunity to work with NepRWA. And just by show of hands for the audience, because a lot of times, you do represent a lot of municipalities. How many here tonight are Quincy residents? Wow, super majority. And then who's joining us from Milton? And upriver communities. Yeah, great. So, welcome anybody to contact me offline. Anybody wants to talk about Quincy, but so grateful that you're all here and spending the time this evening for how can salt marshes save our shoreline. Thank you so much.
And with that, I'm very pleased to hand it over to my colleague Sean McCanty, who is our Director of River Restoration and who has been leading this work for us the last couple of years.
Thank you, Ian, thank you, Margaret, and thank you all for coming. And as I said, we're going to talk about salt marshes in our shoreline. So just a kind of background of what we're going to talk about today. We're going to have some background of the work that NepRWA has been doing in the watershed, in our estuary, and then climate work in general that we've been working on. We're going to talk about a state of the estuary, which is what we're calling this big report we put together on the current conditions. So we'll talk about marsh health, legacy impacts, key findings, then we'll take a bit of a break because it's a lot to get through. And afterwards we'll come back for the meat. What everyone I think is here for is the climate modeling and what to look at next. So we'll talk about flood projections, the way marshes can help mitigate flood risk, the ways we're going to think about restoring our marshes, and what the next steps are. And hopefully this will be all enough for you to generate some questions, and we'll have a good, robust Q&A afterwards. So we'll start with what is and where is the Neponset Estuary. So a lot of people here from Quincy, and as Margaret mentioned, most of Quincy's shoreline is not the Neponset, but we are the Neponset River watershed. So this is the 4 miles of the Neponset River that is tidally influenced, where the saltwater mixes with the freshwater. It kind of starts at the end of Lower Mills in Dorchester and Milton. That's where the Neponset River freshwater ends, and the rest of it is salt mixed. And it goes all the way up to Swan Point here in Quincy, or across the way, the rainbow squash tank that you can see from 93. It's kind of our identifier for the end of the estuary. And as you can see, look at these maps, so you've got a handheld map next to you, in case the font here is really hard to read. The estuary has a lot of features in it. So not only salt marshes, there's beaches, there's mud flats, but also a lot of development. I-93 runs through it, Neponset Ave Bridge, Granite Ave Bridge, spot. And a lot of housing, a lot of people who either live here, recreate here, or work here. So what happens in the Neponset Estuary affects a lot of people all through at various points in their life. And so that's kind of where we are and what we're talking about today, and that's where our focus is going to be. The next question is, how do we get here? So what kind of work has been done to this point, and where are we going with it? And so the work we're going to talk about tonight really kind of builds off of the work that the City of Boston did under their Climate Ready Boston reports, and specifically Climate Ready Dorchester, which is the area of Boston that abuts the Neponset River. That report has looked into a lot of climate projections for the Dorchester neighborhood of Boston. And one of the things that really stood out from that report, and kind of where we kind of chose this as a jumping off point, is unlike a lot of places on the coast, because of the geography of the Neponset Estuary, the salt marshes that we have can do a lot to protect us from storm surge and sea level rise. If it's right on the coast, there's not a lot you can do about it. It's kind of a creeping feeling. But because of the way it's configured, and particularly the Climate Ready Dorchester report showed that protecting the marshes in some way can prolong and reduce the amount of flooding that Butler Key Station experiences, which is an important commuter rail on the trolley line. So we kind of took that as a jumping off point and said that we really need to be involved in the climate work that's happening in the estuary. We want to understand a lot of what's happening. And the first place we as an organization kind of came to this and came at this from is that the community needs to be involved. So there's a lot of climate work being done all across the state by all the various municipalities. It's wonderful work, but a lot of it is very technical and very driven by municipal needs and engineering departments. And we really thought that the community should be driving a lot of this conversation. So we actually did work with the town of Milton through a grant from the Metropolitan Area Planning Council called Accelerated Climate Resilience to develop a estuary community advisory council. It's a long, I'm going to call it CAC for short. And really what that is, we'll talk about who was involved in that, but it really helped center the community in what we were doing and have them act as a real life sanity check on what we were talking about. Making sure that what we think and what the engineers think reflects what actually needs to happen for people who live here. And really what we're going to focus on today is the State of the Estuary Report, which we were able to get funded through a grant from the state, directed through the Division of Ecological Restoration, but ultimately championed by several state senators, Senator Keenan, Senator Tumulty, and Senator Collins, which we're really grateful for. And that, as I said, it kind of sets the stage of what the salt marshes are doing right now. Climate change is a big concern, and think about the future a lot. We're going to take a step back and think about what's happening now and what have we done to them over the last 400 years so we know where we're starting from. And then, as we'll talk about in the second half, we also got some funding from the National Fish and Wildlife Foundation to do this flood modeling and really assess how can the salt marshes help. What if we do this to the salt marshes, what if we do that to them, and how does that affect the formula? So that's kind of where we came from and where we're going. And again, the first thing we realized as we're going through this is NepRWA can't do this alone. We do a lot of stuff, but we're not engineers, and we need a lot of help. So we partnered with some great organizations. So Woods Hole Group and State Landscape Architects are both consulting firms. They're both heavily involved in the Climate Ready Boston reports. So we're building off of their expertise and really shaping what we needed to ask questions of those reports for the Neponset Estuary. We also have learned quite a bit from our partners at the Trustees of Reservations. They've been doing a lot of great salt marsh restoration work up on the Great Marsh, on the North Shore. So we're starting off this journey. They're 5 miles down the road, and we're learning from their mistakes, we're learning from their successes, and we're really grateful to have them as a partner. And last but certainly not least, Paul Kirshen from UMass Boston, is a professor who works on climate change and community participation and really integrating those two features. He's been really helpful in making sure we're, again, following the path that the community is really asking for. And making sure that when we approach these things and when we lay out what comes next, we're keeping the community in mind. And as I said, we started this off by launching a community advisory council, and that's just a big technical name, but it really represents the members of community organizations like Quincy Asian Resources, Quincy Climate Action Network, B8 in Dorchester, a lot of organizations that don't necessarily work on environment as a primary focus, but represent communities that are often kind of left out of the conversation, and we want to make sure that those voices are heard and reflected in what we do. Neighbor associations, Port Norfolk, Marina Bay, we want to make sure that the people who live here can help shape this. And really what we asked the Community Advisory Council was to help us set our priorities. This is what the state reports and all the municipalities think are our climate priorities. Are they your priorities? Does that reflect your lived reality? If it's not, help us identify what else. We started this conversation talking an awful lot about coastal flooding and stormwater flooding, but through those conversations we've had with the community, we've also built in a lot of extreme heat and urban heat effects that isn't part of this work, but is coming down the pipeline and we've added it to a lot of the things we've been working on. The last thing we've asked them to do is encourage collaboration, both among themselves, so people from Quincy Asian Resources talking to people from QCAN, but also, as Ian mentioned, we've been working with all 3 municipalities and the state. And we've been trying to encourage a lot of collaboration between cross-municipal boundaries. And I think it's been a great success of getting these people together, all kind of pulling on the same oar, if you will. And so now I'm going to kind of focus in on that State of the Estuary Report, the current conditions of the estuary. I think the best way to start with this is to ask what salt marshes should look like. If you went out today and went in the Neponset Estuary, if that was your first experience with salt marshes, you wouldn't know, is this good or is this bad? So what we can do is kind of look at what salt marshes should look like, and then kind of take a look at how they actually look like. So we're going to start here on the left-hand side and work our way right. Obviously out here in the open water, where there's no real land to speak of that's exposed, fish live in the water, and there's a lot of issues with water pollution that comes down through Neponset and off the stormwater pipes, but that's kind of what we're starting with here in the open water. As we move towards the land, the first thing we get in terms of habitat is what we call mudflats. These are areas that are exposed at low tide, but often fully covered otherwise. And often we neglect them when we're talking about salt marshes, but they are still important habitat. There's lots of things that live in the salt marshes, in the mudflats. And if you ever go out at low tide and see birds landing on the mudflats and picking around, you know they're picking at something to eat. So it's an important feature of the ecosystem. And then as we kind of move, again, rising in elevation, as we reach the edge of the bank, we're really hitting that, what we call the low salt marsh. And so these are areas that are flooded about twice a day at high tide. So the water comes up over them and they kind of get washed with salt water or brackish water twice a day. And so there's a very specific plant community, animal community that's really adapted to live in this zone. And it's the first line of defense when we think about wave energy coming off or sea level rise. This is the first real land that the water's going to be hitting before it comes towards your house. Moving up from the low marsh, we've got high marsh. Again, a kind of different species pool, a different number of communities. These are areas that normally only flooded once a month during the high tides, like the high tides of the month, the spring tides. And there's also a lot of different habitat features for the wildlife. So salt pans, pools, all provide different habitat from just the marsh grasses themselves. Tidal creeks are also a natural part of these systems. And we get a real sense of the diversity within salt marshes by keeping on all of these. And that's a real through line of what we're working on here. I mean, obviously, I think everyone in this room is concerned about flooding, and we are as well. But we want to keep in mind both the flood risk to us as humans, but also the habitat availability for the wildlife. Kind of hold those things together and see if they can, in what ways they can help each other. And kind of moving up from off the salt marshes, we get our upland areas and transition zones. This is where you get shrubby things, moving to trees, and then eventually you get kind of upland areas where you could safely build houses and stay out of the flood areas. That's what they should look like, right? And I think we all know that's not quite what they always look like. So we can kind of take a look at what makes the marsh impaired. So again, we're going to start on this left-hand side. The first thing we've got here is sea level rise. We're going to let that aside for a moment. We're going to focus on the other impairments we have to salt marshes. But I promise you we're going back to sea level rise later in the talk. But as we move up, the things we can, that industrialization and overdevelopment does to salt marshes, that low marsh area often suffers erosion. So either because there's high wave energy from boats moving back and forth, or additional nutrients or other things that kind of create the plant community or cause the plant community to not do as well. That's moving the that's causing us to lose these low marsh areas to mudflats. And then moving up in our high marsh is often where we see a lot of human impacts that are that exist directly in the marsh. Erosion is kind of like a negative consequence. No one meant to erode the marsh, but here we see a lot of intentional human activities. So there's historic ditching all across our marshes. These could be built for a variety of purposes. So some of them were built in the 30s and 40s as mosquito control ditches. The idea was, we see these areas flood, and mosquitoes breed in this habitat. Let's dig these ditches so they drain faster, and the mosquitoes can't survive. Unfortunately, it's a little bit of a misguided approach because it actually prevents the natural controls of mosquitoes, like fish, from being able to access them and consume the larvae. And that's one negative consequence of the ditches. We'll talk about others. There's also older ditches that were used for agriculture. So in the 1700s, farmers would dig ditches across the landscape to break up salt marsh into parcels, drain the water down, allow it to grow a little bit more like upland, and they would be able to harvest the natural salt grasses as hay to feed their cattle over the winter. And so there's a lot of historic, either healed over or still existing agricultural ditches across a lot of Massachusetts ditches, a lot of Massachusetts salt marshes as well. We also have a lot of things like culverts that carry water from stormwater berms, things that kind of were put in place to keep the water out, but now kind of keep the water out in an unhelpful way where it's sacrificing the marsh behind it. We also have invasive species, especially growing at the edge, in areas where the salt marsh has a lot of water coming in, fresh water coming in. Phragmites is an invasive species that kind of doesn't like so much salt, and when we add excess fresh water coming off of our roadways and other impervious surfaces, we're really creating an ideal location for Phragmites to grow and thrive. So if you're driving over I-93 looking at salt marshes, especially in the late summer and fall, you see the really tall reedy species. Unfortunately, that's Phragmites. It's not a native species. It really kind of hinders wildlife from being able to move through it. We really love to see that replaced with native species of salt marsh plants. Down here, kind of hidden at the bottom, nutrients and pollution, again, coming off that stormwater, and areas where behind these berms you get ponding and supersaturation. So if you're changing the way the water moves across the landscape, which the salt marshes have adapted to, you're unfortunately holding water back, and if you let salty water sit in an area and evaporate, it gets saltier and saltier, and you're eventually killing off plants. So especially, and we'll talk about this in areas of Billings Creek and Quincy, you can see these large pools that never really seem to drain, and no plants can grow in them. And unfortunately, that just diminishes the habitat, but also the protection that we get with the plants. And the kind of last thing is historic fill. So a lot of places along our estuary, we've filled in the marshes in order to build things on top of it. We don't like wet land, we like dry land to build on. So let's just put a bunch of dirt on top of the salt marsh and build our house, build our commercial districts, build our parking lots and roads. And unfortunately, when you build on top of a wetland, you both ruin the habitat that the wetland was on, but also you're building in the area that was historically flooded. So it's not that surprising that down the line, you're going to experience that flooding coming back at you. So that's kind of the impairments we're looking at, and we really want to know now, where do these features crop up in our estuary? Are we seeing this everywhere, or are there specific things happening in specific regions? So talk a little quickly about the Neponset history, and this could be the full hour lecture of the history of Neponset. We're not going to make it that, so I'm going to give you the highlights here. So it's 400 years of industrialization post-European colonization. Neponset also used extensively pre-European colonization, although not usually in a destructive way. And we have a lot of stressors that date back to these 400 years. So development and fill, as we mentioned, those agricultural ditches date back to the 1700s in some areas and interrupt the marsh flow. And more recently, although still happening at the time, stormwater invasive species. So just to give an example of that, this is a map from 1969 of the Sagamore Creek area of Quincy. So you can see this is the Tuttle Creek, Sagamore Creek comes in, winds around like that, all the way back to this little small area down here. And if you look at today, that's the State Street South complex. The creek still exists right here, and actually you can still see that small parcel of it, for those who can't see on this side, comes down off here. So it is still connected by a culvert underneath the complex, but there's a huge set of parking lots and buildings sitting on top of the marsh. And so that's obviously not beneficial to the marsh, and also it puts these buildings at risk for flooding because they're built in a floodplain. So like I said, we're focused on kind of now understanding where these stressors are in the Neponset Estuary. So because we have this branch from the Division of Ecological Restoration, we were able to work with our partners, with Whole Group and Escape and the trustees to really get a sense of what's happening across the estuary. And as far as we can tell, this is the first time the Neponset Estuary has ever been fully evaluated. And I say that, but it means that people have done work in little bits of it. So Boston's done some work, Quincy's done some work, Milton's done some work, the state's done some work, but always in their little, four corners. And so really we've had a great opportunity to find all these historic documents, white papers from DCR, municipal reports from Boston, and really stitch them together and get a better understanding of what the record is for the history of the area and what issues have been highlighted, going back decades. We've also been able to use existing digital data the state has, so there's plenty of great aerial maps. You can do some calculations and figure out based on the aerial maps, is what areas are salt marsh and which ones are high marsh and low marsh and Phragmites, and then you can go ahead and double check that data and make sure it's true. It gives us a way to check all 700 acres of the estuary and get a sense of what's happening on the large scale, and then making sure that it bears out when we go visit the sites. And that kind of gets us to this last bit of what we did, is field work. So going out and making sure that we're taking accurate elevations, depth of the river, logging the tidal cycle in it. So we've got, these are actually maps of the tidal loggers, so what's happening here towards the Baker Dam and Wilson Landing, what's happening down here at the river mouth as it enters Dorchester Bay, what about Billings Creek where it's separated from the rest of the river by the culvert under Commander Boulevard, and what about up here on the marsh platform itself? Is it getting the true tidal flux that we expect it to? And we'll talk about what that ended up being, but it helps us get a sense of, are these marshes getting the regular doses of being washed over by salty water that they expect to and that the plants expect to grow in? And the last thing that fieldwork can help identify is do some surveys of the vegetation and conditions on site. So that's kind of getting a better sense of where the erosion is happening and where the plant material is. And I'll say that the understanding the density of plants and the composition of plants was actually very important for adjusting the flood models, because it actually creates a friction coefficient for the flood models of how much does the water get slowed down by the plant is passing over. So really important to go out and double check what we expect from the digital data from the online maps to make sure it's accurately being reflected in the modeling, which will affect which houses we expect to be at risk and which areas need the most attention the soonest. So that's kind of what we've done in the spring of 2024. So we spent about 6 months doing all this data analysis and field work to kind of coalesce around what are the current conditions. And really what they found is that the Neponset Estuary has had a loss of about 50% of its salt marsh habitat from the earliest records in the 1800s, which sounds like a lot, and it is a lot, but it's also way better than Greater Boston's average, which is more than 8%. So rivers like the Mystic and Charles, the Charles has no salt marshes, the Mystic has very little. Neponset actually, relatively speaking, has a lot of salt marshes left, which provides a great opportunity to say, if you were to do this kind of work and expect to have salt marsh and nature-based solutions in the Charles River, you have to start from scratch. You have to build a floating wetland in the Charles and build it out from there. We have salt marshes to start with. All we have to do is keep them healthy and fix some of the issues they have. So it's a really great advantage that Neponset has. The other big finding is that they kind of classify this into 3 distinct zones in terms of what stressors are happening in the estuary. So we have an upstream area, so the Baker Dam up to Granite Ave Bridge, this kind of section here in Dorchester and Milton. There's the middle reach from Granite Ave Bridge to the Ponds Ave Bridge, so where Pope John Paul II Park is in Dorchester, and kind of Quincy, Milton line, separating Quincy and Milton. And then lastly, the downstream reach. So kind of everything beyond the Neponset Ave Bridge, Port Norfolk up to Tinian Beach on the Boston side, Quincy, Billings Creek, Commander Shea, Quincy Shore Drive area over here up to Swan Point. So it's really important for us to better understand what's happening in each of these regions specifically, because even though we can assess what's happening overall in the estuary, when we get down to talking about restoration, every restoration project is very local. You got to deal with the local conditions, and so it's important to understand what's happening at those specific sites. So we're going to take a quick moment to walk through those sections. Starting in upstream reach, this is the area that is the least salty, right? It's coming off of the Neponset River. There's a tributary here from Umpqui Brook in Milton that eventually becomes called Gulliver's Creek. So this area is the least salty and most mixed with fresh water. And what we see is some effects from that. So there's a lot of Phragmites dominance in this area because Phragmites doesn't like salt, so it's going to gravitate towards the areas that are more fresh. There's also a lot of historic fill. So a lot of this comes from when the river was dredged for navigation purposes. They pulled all the sediment off the bottom of the river and they needed somewhere to put it, and they put it on the marshes. So Dorchester Marshes and this area next to Gulliver's Creek, a lot of that wet, sandy, silty clay material was put on top of the marshes as a way to get rid of it. And unfortunately, what that does is change the elevation of the salt marsh and make it so that the salt marsh is not the correct elevation to grow native salt plants, but the perfect elevation to grow Phragmites. So again, if you're going over I-93 and you look over the side, you'll see waves and waves. All of this area is covered in Phragmites. Most of the Dorchester marshes are as well. And that's kind of what we see in this upstream area. So now we know what our biggest focus is here is Phragmites and some historic fill. So when we think about restoration projects, we keep that in mind. In the middle reach, so again, we're talking about here on the other side of Pope John Paul Park up to the Quincy-Milton line, we're seeing a very different scenario. Obviously, Boston, we still have historic fill. The park is sitting on top of an old drive-in movie theater and landfill. And if you ever go next to it, you can see these people rowing. Here's the river. There's the park. It's way higher than you would expect it to be. That's because it's sitting on top of a landfill. And so that's still a historic fill issue. But you can see right here next to these people rowing, there actually is some salt marsh fringing the edge of the park. You can see that kind of going up along the Boston side as well. And it's really important that we keep, it's very vulnerable. It's a small section of it, so we want to keep it where it is and keep it healthy. On the Quincy side, we're seeing a very different story than we saw in the upstream. We're seeing a lot of ditching. We're seeing elevations actually below what they expected to be. There's kind of a little bit of erosion, a little bit of slumping at those marshes. So it's the opposite of fill. They're kind of sinking under the water right now, and there might be a way to improve that. We'll talk about a bit. And of course, I can't leave out on the Quincy side. There's also that Skate Street South Office Park complex sitting on top of the marsh, which is a fill issue and also a connectivity issue. Right? So the Sidewalk Creek can't really connect all the way through as efficiently as it normally would have. And then our last section, the downstream reach. So here on the Boston side, that's the Port Norfolk area down to Dorchester Bay. We've got, again, kind of fringing marsh. There's not a lot of area for big salt marshes to grow. We've developed all the way up the edge, and all that's left is the very edge of the waterway that the salt marshes can grow. So that's an issue there, but we want to make sure we, if we're thinking of projects in this area, we want to prioritize projects that keep this fringing marsh habitat alive, and maybe also look about how to expand it inland a little bit. On the Quincy side, we actually have a huge section of, I would call it inland salt marsh here. Billings Creek goes all the way under Commander Shea Boulevard, almost all the way across to the Wallaston Beach side, and a lot of it looks just like this, which really looks like a lot of great salt marsh, except for these large ponds you'll see all throughout it. And that's the issue of that ponding I said. So when you change the elevation of the marsh, you put berms across it, you catch the water behind it, and these big pools of water can't drain away, and you kind of have a super salty pond that sits on top of the water and unfortunately does all the plants. So when we think about how we restore this area, we would think about what are the ways we can keep these ponds draining, how can we breach some of those berms, and how can we get this flushing with the normal, how can we get flushing with the tidal sequence, or tidal cycle we would expect it to have. Okay. All right, so that's a lot to kind of walk through all these different sections, but really what I hope you took away from that is even in all these sections, there are different stories of what's happening. In the upstream areas, it's a lot of invasive species and fill. In this middle section, we have a lot of ditching issues. And up here in Billings Creek, we have that ponding issue and loss of tidal connection. So as we think about projects to go along with this and how to fix it, it's important we are fixing the right problem. We can't go in thinking we're going to do invasive species control in Billings Creek. There's not a lot of invasive Phragmites there. And similarly, you can't go and say, well, all I need to do is drain all these ponds that exist here in Billings Creek. There are no ponds to drain. So I want to make sure we're focusing on that. And this is a little map of where all those structures are found. So I'm not going to walk through all of them, it's a lot, but if you see these little orange dots, that's invasive Phragmites. You can see there's a little bit up here, right at the edge of the middle reach, a lot more orange dots all throughout here. And that's kind of emphasizing the issue of Phragmites is an upstream area freshwater problem. You see almost none of it here. You see a little bit of fringing on the edges up there, but very few invasive species concerns along this section. All right. And so that's all well and good. Now we've highlighted all the problems kind of made a catalog list and written it down. But I can hear you all asking, what about climate change? So the reason we kind of focus in on these historic concerns, the legacy impacts of industrialization or ongoing infrastructure decisions to put stormwater out into our marshes, is that we want the marshes to be as healthy as possible before climate change effects really start impacting them. If we think about what makes the thing healthiest, do you want to face an illness when you're already sick, or do you want to face an illness when you're as healthy as possible? So we want to get them in the best possible position to deal with that. And a really important point here is that healthy marshes naturally have a capacity to build up elevation and migrate inland. So think about the geological record of how salt marshes have handled sea level rise and sea level retreat in the past. They've what they call accrete. They build up elevation over time. And when the sea levels rise, they push their way inland. They kind of move with the elevation up into the upland areas and turn into salt marsh. And when the ocean recedes back down, they kind of build their way back out into the ocean areas and take over those mud flats. That's what salt marshes normally do. However, they're normally doing it at a time scale that's much longer, right? So what we're experiencing with climate change is faster changes in our sea levels than the marshes can pretty much naturally adapt to. So we want to get them in the best shape as possible, and we also want to help them both migrate and control their accretion rates and help them out however we can. So that's kind of where we're at as we exit the State of the Estuary report and think about the flood model. So I know that was a lot, so we're going to take a little bit of a break, get up, stretch, grab some water, grab a cookie, we'll come back, the best. So as promised, next we're going to talk about the work we did under the National Fish and Wildlife Foundation grant. And again, I want to keep in mind that we have two real goals here. The first is protecting the salt marshes for the wildlife that lives there, but also the fact that we live in the estuary. We want to make sure that we're not experiencing undue flooding. So we got to keep those two goals in mind as we do this. Sometimes those are different solutions, but we want to try and get both outcomes at the same time. So we're going to talk about modeling and climate change next. Now we've got our baseline conditions in hand. We're going to be able to model future projections for sea level rise and storm surge. And some people in the room might be asking, why not use FEMA? There's a whole federal agency that does this and creates flood maps. Why wouldn't we just do that? Why are we reinventing the wheel? And the issue is that FEMA flood maps are all based on where flooding has already occurred. They're not projected. They're based on what's they're based on where flooding has already happened. It's really helpful for planning out what's most at risk today, but not what's most at risk in 30 years and 50 years. So instead, we're going to use we're going to modify the statewide coastal flood risk model. It's called the Massachusetts Coastal Flood Risk Model, and then it's a catchy name, MCFRM. And you kind of see this little graphic as goes through and catch it at the right time. We're going to walk through present day, 2030, 2050, 2070. There's a lot of colors happening here, but just keep your eye on the darkest blue colors. As we go from present day, out into 2030, 2050, 2070, that dark blue color is getting larger and larger. And what that's representing is areas we expect to flood at least once a year. So going from around the river channel to kind of exceeding all this area, all of northwest Quincy, down into the Newport Avenue area down here, and Gallaudet Boulevard in Boston. So that's what we're kind of expecting to see based on from the state model. But again, you might ask, there's a state model. Why wouldn't you update the flood model? And it's developed statewide. It's meant to be used on the coast. However, and I kind of made allusion to this before, what's happening specifically in the Neponset Estuary needs a little bit of extra calibration. So the exact conditions of the salt marsh health and what vegetation we have here, the amount of fresh water coming in off the Neponset River and its tributaries, and those existing channels and ditches all through the salt marsh are all going to affect this flooding projection. I would say that the state level model is good enough for government work. That's at a huge state level. But if you're actually asking, is my neighborhood in danger, or is my neighbor's neighborhood in danger? You need to dial it down to what's happening at the local level. So that's what we're hoping to do, or that's what we were hoping to do, and I'm going to show you what we found from it. And so when we think about climate change, really we're asking what's coming. right? So we want to know both the near-term risks and the long-term risks. We know what's going to happen in 20 years, but also 50 years. This flood model is going to help us understand that through looking at storm surge risks. And so I want to talk really quickly about the numbers here, because we're going to switch what I think normally people think about in storms, like the annual storm, the 10-year storm, 100-year storm. We prefer to think of these in terms of percentages, and using, again, another great government word that's like really long. It's called the annual exceedance probability. So what's the chance you're going to get a storm that severe or more severe in a given year? So at 100% chance, that's an annual storm. You're almost guaranteed to have that storm. 10% is your 10-year storm, and counterintuitively 1% is your 100-year storm. You have a 1% chance every year of having a storm this severe or worse. So you'll see as some of these graphs show, it's labeled in percentages of annual exceedance probability, but just remember that a 1% storm is your 100-year storm. And really what you can see is what this looks like. This is a graph of the projected changes from when models were first developed, in what was measured in 2024 during the Neponset Estuary study, and what the projections are for 2030 and 2070. So we're going to ignore these values down here, but we're going to focus on this MHW, mean high water. So you can see right now, mean high water in the Boston area and the Neponset Estuary is about 5.05 feet. By 2030, the projection is for 6.1 feet, and by 2070, it's 9.3 feet. Now, the real question here is, there's a lot of uncertainty around climate modeling. Most of that uncertainty is about when you reach these values, not if you're going to reach them. The question isn't really, are we going to see 6.1? It's, do we see it in 2030 or 2040 or 2050? So at the end of the day, we're using these projections, maybe they'll be correct or not. It's really just a matter of when we see it happen. And then on top of that, you get these storm projections. So the annual year flood in 2030 is projected to be 8.3, the 10-year storm 9.4, the 100-year storm 10.6. So just imagine, if the current high tide level is 5.5, the 100-year storm in 2030 is projected to be 5 feet higher. By 2070, it'll be 9 feet higher. So just kind of get a sense of what we're talking about in terms of what's coming down the pipe for us. And so like I said, we want to know what's happening, both storm surge risk, but also when. So kind of right about now, soon in 2050, or kind of in the future in 2070. And that's going to become important because we can't do everything right away, right? So we need to do a little bit of understanding our flood models to know what's important that we do today and what we need to plan to do tomorrow. We can't, no one has enough money to do it all right now. So we got a little triage and prioritization happening. And the last thing that we really want to focus on is, it's called sunny day flooding. So just the monthly high tide. It doesn't need to be a storm for this to happen, it's just the high tide of the month coming up. And so if you've ever driven down Morrissey Boulevard and found it closed because of the tide flooding, and think, it's a bright sunny day outside, what the heck? That's what's happening in this monthly high tide flooding. And that's what we're really interested in happening and seeing what the projections are for the Neponset, so we don't end up a lot like Morrissey Boulevard. And so as we look at this, we're also going to ask ourselves, because of what we saw in the Pemberley Purchase report, we can ask ourselves, how do salt marshes affect the flood projections? How does it benefit us by reducing the flood risk? And so we looked at a number of approaches. The first is what we're going to call the no action approach. What if we do nothing? What if we just let the marshes do whatever they're going to do and climate change happen? Or what if we restore and adapt where they are? So we're not going to really step through the no action scenario, except as a comparison purpose. But really what the projections are is if you do nothing, most of your salt marshes are going to either erode away or turn into mudflat. This orange is mudflat area. And so you're going to lose a lot, almost all the salt marshes in the Neponset. If we do nothing, will transition into mudflat or erode away, leaving us with no marshes and a lot more flooding. So the first scenario we're looking at is what we call restore and adapt. What can we do to keep the marshes we have where they are and healthy? So that's keeping, kind of addressing those stressors we talked about during the state of the estuary, addressing Phragmites growth, healing over those ditches, addressing some of that super ponding, and also helping it maintain elevation. On top of that, we also looked at 4 different approaches of helping the marshes expand. like I said before, marshes naturally build up in elevation, and they also naturally move upland when sea level rises. They kind of move to match the right elevation. And so the issue with that in the Neponset is we've developed everything up to the edges. There's not really much available land for them to move. So we've kind of focused this on 4 different approaches of all increasing conflict with existing land use. So starting on number 1, limited migration, so that's just letting the marshes move into forested areas, upland areas that are natural, that aren't really being used for anything. Number 2, okay, what if we also take over open spaces like parks? So maybe there's some areas of parkland that can convert to marshes that can still be used as a park as well. Number 3, what if we let it use some developed areas? What if we rerouted some roads? What if we took out some parking lots that we don't need? And then the 4th one, the kind of the biggest impact to existing infrastructure is what if we let it go wherever the elevation suggests the marsh could go, regardless of whether there's a building there or not. So again, I'm going to stress right now, no one's recommending this. We just want to look at what would happen. It kind of helps us set the upper bound. Like, if you did as much as possible, what's the maximum salt marshes to help us? And that's just really helpful for us setting the stage and getting a baseline for what could be done with natural solutions. And then when we know that, what other what other hard infrastructure solutions could coexist alongside the salt marshes? So again, we're now asking this question we're asking 2 different questions at the same time. What's the risk, what's the benefit in flood risk reduction? How much areas that would be flooded are not going to be flooded? And also, what's the ecological benefit? What's the area for fish and wildlife to habitate and exist in our salt marshes? And you can see they're rising together, but not necessarily at the same rates. And so this is a graph of our different scenarios. So doing nothing, we're going to start at 0 here. As we move to this, if we just restore the marshes we have and let them migrate into just open natural land, like upland forests and the shrub areas next to the salt marsh, you get a huge jump up in both flood risk reduction and ecological benefit. You save a lot of marshes by 2070, and those marshes are helping protect the houses behind them. As we move through and say, okay, what if they take over parks? What if they take over some parking lots? You still get increasing ecological benefit because you're getting more salt marsh out of it. There's more area for birds and wildlife to live. But the flood risk is pretty flat. You're not seeing a whole lot of improvement by converting over a parking lot in terms of flood reduction. And it's not until this last one where we kind of let the marsh take over its full extent that we see another jump in flood risk reduction. And again, I'm stressed, no one's suggesting we do this. It's important to just understand what this would look like and what it could benefit. That way we can plan out things and have a more informed discussion about it. So both because there's kind of a flat line here for flood risk and because we don't have for every talk today, we're going to focus on the no action scenario, this scenario 1 of just leaving the marshes where they are, and this extreme example over here in number 4. So here we're going to compare that approach 1 of restoring the marshes against the no action scenario. So these maps, we're going to see a lot of these maps, but the best way to read these is anywhere it's in blue is an area that is going to be flooded in both approaches. This is a map of annual flooding in 2070. So regardless of no action or restoring the marshes, anywhere in blue is going to still be flooded. The difference area is this light purple. So this is an area that if we do nothing, it's going to be flooded, and if we restore the marshes, it's not going to be flooded. And we're looking at NepRWA, we'll take a closer look in a second at a specific area, but you can see this includes areas like the Butler Tea Stop over here in Dorchester, alongside Granite Avenue in Milton, this area behind the State Street Complex in Quincy, and along here on Commander Boulevard up into Shore Drive. There's a little bit of purple here. So those are all areas that by 2070, in an annual storm, if we did nothing, we'd expect to flood, and if we just restore the marshes we have, without taking any buildings out, we'll see flood reduction. And what that really looks like is, ignore the negative numbers here, it's obviously, it's a kind of double negative. These are things that would not be flooded, so it's a change from the baseline condition of where we're doing nothing. So what that means is 99 units of housing would not experience flooding if we save those marshes. It's 68 buildings that wouldn't experience annual flooding. It's almost 3 miles of roadways and trails. and it's almost 25 acres of open space that would still be usable and wouldn't flood every year. And if we take a look at what that looks like kind of at the nitty-gritty scale, so this is State Street complex. We're going to look behind this area. So we're in Quincy, we're going to focus on this area. And again, blue is areas that would still be flooded in either situation, and purple is areas that would no longer be flooded if we restore the marshes we have. So here, Division Street, and over here up towards Newport Avenue, we get areas that are no longer going to be flooded. And even in the areas that still would experience flooding, we're getting depth reduction. So this area, Perry Avenue, is still going to flood once a year in 2070 under the predicted model, but it's going to flood a foot less. And that's going to be a big deal if you live on that street, dealing with a foot less of water. It's going to be very important for your, whether it affects your property or not. In State Street Top Complex, you're getting it's 0.7 feet, which is about 8 inches of depth reduction. So that's the difference between whether the parking lot is mildly flooded or impassively flooded in some situations. So it's important to kind of both understand if we're talking about areas that would stay dry and also areas that would be less wet. It's kind of an important thing to keep those both in mind. And that was looking at annual flooding. And as mentioned, we want to also think about the sunny day flooding, the Morrissey Boulevard situation. And really this came out of the community advisory group to say, that's all well and good. I can handle a lot of things that happen once a year. I can call out of work one day a year. What I can't do is call out of work every month at a random time. Because this monthly flooding is based on the tidal cycle. It might be 8 a.m. on Tuesday when you gotta get to work. It might be 5 p.m. on a Friday when you're coming home from work. Maybe you can't get to your house anymore. So we really heard from the community that this monthly influence is going to be a lot more relevant to their daily lives. And if we look at that, just restoring the marshes again, we're seeing purple, we're seeing a little bit more purple on the edges here. That's almost 300 units of residential housing that isn't going to experience flooding. 76 buildings, 3.6 miles of roadways and transit lines, and 31 acres of open space. So these are all areas that you'd be able to use except for potentially once a month. Except for potentially once a year when we get into the annual flooding. But that makes a big difference for anyone living in this area. Is one point. If Canary Boulevard is flooding, you're basically living on an island no longer. You're not living on a peninsula any longer. So that was approach one of, again, just kind of restoring the marshes where they were and letting them keep pace with sea level rise. Now we're going to jump to the far extreme of approach 4. Again, this is kind of removing buildings, removing anything in the marshes way. And I'll stress again, no one's recommending this. But again, we just want to take a look at it. So what that looks like, anywhere you see in a red outline is a building that's being lost. So there's a lot in Port Norfolk, there's a lot of commercial buildings in that State Street South complex, and a little bit of buildings along Grand Ave as well. And the reason we want to look at this is the modeling suggests it's not really going to make a big difference in the annual flooding, but it's going to make a big difference in that 1% or 100-year storm. Those big storm events, this is where you really see the change. So again, you're seeing some purple areas, and it's different areas. So most of the purple we saw before was in this area, all along the edges of the marsh. Here we're seeing further into Quincy, this area is expected to flood in a 100-year storm. That would not flood if we restored these marshes. Now again, I'm stressing, no one's suggesting we should take out all these buildings, but it does give us a sense of like, what are some questions we can ask, and what are targeted ways maybe that we can work on saving this area a little bit more, or some nature-based solution and maybe some artificial solutions that can get us the same results in this area. It does also provide a substantial ecosystem benefit. It's about 172 extra acres of salt marsh spread throughout the estuary. But the reason we focused in on it is this is the only thing that makes a difference in those extreme storm events. Saving the marshes we have helps us on a year-to-year basis, but it doesn't help us with those extreme events. So we need to look towards other things in our toolkit or more extreme approaches if we really want to stay dry in those 100-year storms. And again, kind of taking a deeper look, what that looks like here. So now this blue flooding is a very light blue shade to represent the 1% storm, the 100-year storm. so it's the dark blue, but still purple is areas that are being scared to flooding. And look at the values of depth reduction, even in areas that still flood, that's 4.3 feet of depth reduction here on this, north of the red line, south of North Quincy Station on the red line. And North Quincy Station here is still going to experience flooding, but it's going to be 3 feet less of flooding. So that's the difference between the trains being able to run and the trains being able to not run for weeks afterwards as they repair critical infrastructure. 1.3 feet in Newport Ave, 2 feet over here on Division Street, 1.5 foot over here in City Bay. So that's kind of what we're looking at. Just again, understanding what the projections are and what this could mean for people who live in these neighborhoods. So, overall takeaways is, what we saw from approach 1 is that just restoring the marshes will provide significant flood risk reduction at the monthly level in the near future. So, monthly level in 2070 and even near future annual flooding in 2030 and 2050. That restoring the marshes and keeping them healthy will buy us a lot of flood protection. And it's really important because it's buying us not only flood protection now, it's buying us time to think about and implement longer term solutions. All of this comes with costs and difficult decisions. Approach 1, which doesn't require anyone to move any infrastructure really, it's going to cost some money. We're going to lose a little bit of upland forest area to salt marsh, but I think most people would make that trade. And we're going to get some infrastructure that needs to be relocated. Some sewer pipes and some gas lines may need to be relocated as some of these areas flood. But ultimately, that's not a lot to do relative to approach 4, but the cost is much higher. You're relocating buildings and transportation lines and a lot of infrastructure. So approach 4 has a lot of trade-offs that would make it a lot more unpalatable. So, as I said, approach 1 is buying us a lot of additional time to assess other solutions. So in some of those areas we might talk about managed retreat. Is this the best place for your house, or is this the best place for your business? If it's going to cost so much money to keep it accessible and available, buys you a little bit of time to figure that out and also work through what retreat would look like. It also buys some time to think about harder infrastructure. So there are conversations around levees and seawalls and things to put in place. That takes time, and ultimately we expect a solution that would use both nature-based solution and hard infrastructure to work hand in hand. It buys a little bit of time to work out the details of that, so we don't lose our marshes and we don't wall ourselves in off the ocean. We think there's probably half a meeting in there that we have time to think about. If we restore the marshes, we have to keep them healthy. So, we talked a lot about restoring these marshes in this approach 1. We'll fix all these structures we talked about in the Neponset Estuary. We're going to keep them matching elevation. What does that actually look like? So right here, I've mapped out a couple of different potential restoration actions. Again, these are what we use in specific areas going to be dictated by what you have there. So you're going to do invasive species management in the upper areas where you've got a lot of phragmites and freshwater input. You're going to do tidal flow restrictions over by Swan Point and Billings Creek, where there's a culvert that slows the water moving into the Billings Creek marshes. These are generally listed in order of difficulty. It's not, some level of erosion control is not that difficult to manage. It could be as simple as a no-wake zone to stop boats from causing erosion. And there's obviously more intense things you can do to kind of stabilize already eroding marsh. You can manage pollution, both point and non-point pollution coming off of roadways and other impervious surfaces. You can manage our phragmites problem through our ongoing efforts to kind of cut it back, treat it, and restore native marsh. And those tidal flow restrictions, you can update those culverts, you can make them the right size, you can make them the right depth in order to get the flow through the system. You can also, in areas like Sagamore Creek, where the State Street complex is put on top of it, maybe there's a way to reconnect that channel a little bit better so that you get the right tidal flow through it, and you make that disconnected salt marsh a little bit healthier. These last 3, we'll call ditch remediation, runneling, and thin layer replacement. They're a little more complicated, so I do want to walk through those. So ditch remediations, these are, again, either mosquito ditches or old agricultural ditches in salt marshes. And we've learned a lot from the trustees and their work in the Great Marsh But when you have these ditches, not only do they kind of break up the lay of the salt marsh into nice little squares for farmers to harvest their hay on, it also lowers the groundwater. So the groundwater is going to follow its way down to the lowest point of the trench and drain out towards the ocean. And you've got what was wetland salt marsh is now very dry upland, artificial upland that they built on top of it. It's very hard for salt marsh grasses to grow on it. So the best way that they found to remediate these, called ditch remediation, is to fill in these ditches with native salt marsh grasses. So kind of harvest the marsh grasses every year, plug up these ditches a little bit. It's the natural thing that would normally become peat anyway. Allow it to kind of naturally decompose and turn into a peat layer underneath the salt marsh, catch sediment and kind of plug up this ditch. Not with external fill, but with native salt marsh grasses. What you get is the groundwater kind of re-rises to meet the surface level. You're kind of hydrating this area, which lets the marsh grasses grow as best they can, and that actually helps them grow and accrete that elevation that we hope that they can do to keep pace with sea level rise. So by kind of restoring these ditches, we're hoping that provides the marsh the tools they need to grow on their own, kind of get that gap a little bit less. And on the other side, there's a technique called runneling, which is also a great way to think of it as a micro-channel. So we don't want to create these ditches that lower the groundwater, but we do want, in some areas, to move this stagnant water off the marsh channels. So like in Billings Creek, where those big permanent ponds are, what are ways you can drain it? And so creating some surface runnels, some areas that will help drain off the water, will help disconnect those permanent pools. And I did have a question in the break. Those pools are important habitat for birds. We're not saying get rid of all the pools, we're saying get rid of the permanent pools. So what should naturally happen across the landscape of a salt marsh is pools crop up for a few years and then they fill back in and a new pool pops up somewhere else. So it's an important habitat feature, but these permanent pools are a problem created by the infrastructure we put on the salt marsh. And runnels are a great way to fix that and drain off that surface water that shouldn't be standing there for that long. And the last one, and possibly the hardest one for us to work on now, although things are getting easier, is what's called thin layer placement, sometimes called thin layer deposition. And the idea here is salt marshes right now are, especially those we have in Neponset, are prevented from migrating upland. Right? There's a parking lot in the way, there's a house in the way, there's something in the way up here. And so as sea level rises, it's going to drown out the low marsh, turn it into mud flats. It's going to drown the low marsh and turn some of the high marsh into low marsh. And this high marsh has nowhere to go. It can't migrate its way upwards. So instead, what you do is apply a thin layer of sediment on top of the surface of the marsh, just enough for the salt marsh grasses to grow in and amongst it and on top of it, and build it into the peat layer on top of it. So this is what's called thin layer placement, basically putting on a little bit of sediment at a time, and it doses that the salt marsh can handle, and you're artificially inflating the elevation of these marshes. And what we hope to see over time is that the marsh grasses kind of grow in and amongst it and on top of it. They build that sediment into their peat layer, and they're able to rise in elevation at a little bit better pace to match sea level rise. So some great work has been done by Mass Audubon and others who are kind of currently pioneering the state regulations around thin layer placement. It's an area of active improvement and understanding. And we're hoping by the time that we're ready to implement it, someone else will have worked all the things, but if not, we'll be happy to join that conversation. And I know we're running out of time, I want to save some time for questions, but I just want to talk about the next steps for our project. So now that we've identified the current stressors and what the flood modeling projects, we've really developed these 3 priority projects. So these projects are distributed across the estuary, and they're intentionally representative of different areas and different problems. So we've got one in the upper watershed, or sorry, the upstream area, one in the middle, and one in the downstream area. We've got areas that are fully owned by the state and DCR, we've got areas that are owned by municipalities, so Milton and some private landowners own this parcel here. And then you've got in Lower Creek, there's some areas that are owned by DCR, the city of Quincy, and private landowners. That's kind of the hardest one to work with. We've got too many opinions happening all at once. Well, it's an important feature, and we want to kind of pioneer our way through that. And also, you're focusing on different things. So again, up here, phragmites and ditches and subsidence, that super ponding and tidal connection. So the idea here is we've highlighted 3 areas to start our work on. And by working in so many different areas at the same time, we're building the skills to say, okay, now we figured out how to do this here. We can do that all across the downstream section. We learned how to deal with the ditches and subsidence here. Let's apply it on this side of 93 as well, and maybe in the Boston area. We learned how to deal with the fragmites over here. Let's transport it to Dorchester Marshes. So we consider these priority projects catalytic in that they activate future projects down the line. And we have put one of these projects forward for state funding. We're hoping to hear back pretty soon. We're really excited to advance that project. And with that, I'd like to answer any questions you have. If you'd like to learn more, you can go to our website, neponset.org/estuary, read these reports. So really fantastic work being done put together by our partners. A lot of extra information in there. And I'm happy to answer any questions you guys have.
What was the website?
Yeah, so we put the funding into the Riverside, Milton, and Saginaw Creek area of Quincy. Actually, I'll just really quickly, we don't have time to go through this, but this is what the project looks like. So this area is owned by the Village Conservation Commission. This is owned by Fox Rock, which is the entity that owns most of the State Street South complex, and this is actually owned by a church in Somerville that run the radio towers of the Quincy area. Any questions?
Are you, that area you just showed, is there an ongoing restoration at all in there? Or is there any testing, like of tactics to do this? I don't see hardly any actual action except the Romney Marsh and I think it's Revere. But that was an inland.
Yeah, so there hasn't been any active work in the Neponset Estuary, except if you go back long ago in 2005, the Dorchester Marshes, there was a project to restore the Dorchester Marshes that DCR was doing. It was eventually stopped because they were unwilling to test the sediments for contamination purposes. That kind of stopped that process in its tracks. But the goal of this is to advance those projects to implementation. So if we get the funding for this Milton Quincy parcel, it would be bringing us up to the permitting level and we could start doing restoration work.
I just want to add to that. So there in the ECO one-stop through the Executive Office of Energy and Environmental Affairs, Mayor Koch put in a letter of support to your application. And simultaneously, I also drafted for the City of Quincy also an application for MVP. You guys are after MVP, right?
MVP and CCO.
And CCN. And we did MVP and coastal resilience in that same portal. So for another Sagamore Creek piece of the puzzle that actually connects. So
Yeah.
a couple of things that are happening simultaneously between the nonprofit and the municipality in that area.
Yeah. And great synergy to have those go at the same time. Yeah.
Are those fragmites right there?
That is fragmented. Unfortunately, it's hard to get a shot of the marsh that doesn't have the fragments in it.
So in Quincy, Town River Bay, the broad meadow, which is now was restored several, I want to say 15 years ago now. Do you consider that to have been successful as a model?
I don't know too much about it, to be honest. It's outside the Neponset River
Sure,
watershed.
it is.
But I do know that part of that project was funded by some settlement money that happened in the Neponset Estuary that was transferred over. So I don't know too much about it. I'd love to learn more about it.
So we live overlooking that, and busy watching the two-head of Osprey there.
Nice.
Flying around to take off when the light is going like this actually. But yes, I mean, even during the restoration work, the men would stop working at 5 and the birds and the wildlife was there at 30 seconds later.
Yeah.
And it's...
A lot of the wildlife is very well adapted to our life cycle.
And it no longer burns, it used to burn frequently.
Yeah.
It doesn't do that anymore, it just seems to be...
Yeah, if you make it wetter and fix the hydrology, you're fixing a lot. And the deposit marshes used to burn all the time too, and sometimes still
You
do.
could talk about that.
Not hijacking your meeting. It was an Army Corps engineers funded projects for the one map in the City of Quincy. We did have some mitigation money from a project at one Neponset that I was involved back at the end of the day of bringing that funding to then expand it, right? Every dollar we brought in had a $4 Army Corps match. Over 200 species of birds have been counted. It's amazing. It's a great success. I'm happy to their topic is Neponset, but happy to offline talk talk with anybody about, love that.
You talk about migrating, the marshes can kind of grow and kind of push out. And then you say, you know, because I live in Quincy and over where State Street was and things like that, they are planning more development over there. How do you work with municipalities and kind of asking them to think about the future and not just the immediate needs, especially when you're building such huge complexes that really don't have any benefit from real affordable housing or anything like that?
Yeah, the way we do that is we get Margaret to come to these talks. Who's part of the conversation. No, I will say that we've had great success working with municipalities and getting municipal staff to these conversations. A lot of them don't work on development issues specifically, and sometimes, especially in Boston, there's the environment department doesn't know what the development department is necessarily doing. I mean, they know, but like sometimes they make decisions the environment department would have made. So we do what we can to work with our partners, but we do also, as a nonprofit, we also have an advocacy side of things we do and advocate for sensible affordable housing and the best development practices.
Or better zoning,
Yeah.
And more controls over what can be built in certain areas.
Maria.
Yeah, first of all, when they built, the DCR made the John Paul Park and the Finnegan Park, they did do some small projects to encourage the marsh to grow along the edge, and it has worked. But it's small, so there have been some projects to increase the marsh.
That's true.
But secondly, I was wondering about the area over at Marina Bay there. I mean, most likely the water used to come in from the northern end to the other side. Is that completely blocked off now? And if so, could you open that up? Would that help to restore that marsh area?
The north end is completely blocked up. Actually, it's interesting on my directions are on the east end, there is a culvert that connects them. So in terms of water connection, there is actually kind of like an island of Quincy that goes up to Squantum because that salt marsh flushes with water from both sides. And there are some great maps that Sally Owens has of the historic area in Quincy and kind of how those peninsulas were in fact islands at high tide. Yeah, I think some opening up some of those berms and reconnecting some of that.
What's the other road that goes into Marina Bay? Is there any places where the water goes under there? So that
I don't think there is.
Well,
Yeah.
are there?
Victory Road, but yeah, there probably are items on the show.
Yeah,
Maybe
I
they
don't know if
could
there's
be
anything going. I
increased.
know from the east side there definitely is.
That's kind of like what they're doing down at the Everglades, opening it up.
Yeah.
And as far as development is concerned, I'm sorry to say I don't have any faith in the city of Boston or the city of Quincy in protecting the shorelines and the marshes. I'm sorry, but that's just the way it is. I've been involved with a lot of projects and they all get permitted and it's really sad.
I just want to point also that the 8 o'clock, I want to respect everyone's time, so you've got to move on. I do want to say that we've got Nancy and Karen outside with flyers about NepRWA events. I'm sure you grab one on the way out. But I'm happy to stick around and talk to anyone who wants to talk. Keep going.
Yeah, just one final thing. I brought this up last time, but taking the State Street complex as an example. Those buildings were built in the 1980s. They are approaching the life cycle, okay? It might not, and I think it's worth doing a land assessment of the areas that I think would be valuable to have as a marsh restoration. Because if they go to refinance now, they're probably not going to be able to refinance because of all the external things about, okay, flood insurance. I don't know, any insurer does insure them.
Well, FEMA does, that's what they do. That's why all the stuff gets built.
Anyway,
It's the same.
That's something to think about. As I said, you do this approach well and you buy yourself some time to have these long conversations, you reach the life cycle of some of these areas and say, is the best use of this to redevelop this or to switch over to these? Thank you.